Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023 Paper 1 Variant 1. In today's lesson, our main focus will be on mechanics and waves questions. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 11 says the driver of a car applies two parallel forces to a steering wheel as shown in the figure. Each force has a magnitude of 15 newtons and acts in the direction shown in the figure. The steering wheel has a diameter of 0.40 meters. What is the torque exerted on the steering wheel? So in this case, torque of a couple, simply we can calculate one force times perpendicular distance between forces. So we have to take perpendicular distance and we need to take one of the forces. These forces are equal in magnitude. So we can draw this line here. So this is line of action of one force, and we can also draw one line here. So this is over another force, and the perpendicular distance between these two, simply we can draw one perpendicular from here. So this line we can draw here. Now simply you can see in this case, if this angle is 65, this also has to be 65, and this side of triangle is 0.40 meters. So we are interested in this perpendicular distance because you can see this angle is 90 degree and here angle also will be 90 degree. So this is also has to be total 90 degree angle. So this side, simply you can find out this will be equal to 0.40 sine of 65. So this is sine of 65. Now simply we can plug in values here and we can find out torque of the couple. So the force we have, that is 15, and the distance we have 0.40 sine of 65. So if we solve this one, we will get 5.4 newtons meter. So there should be distance between the units. So if you write on 2 units, there should be little distance between them. So it has to be Newton meter. So if you write on like this, this is not right. But if you write on this one, this is right. Mean the prefix and the unit you can write close to each other, but when you write on 2 separate units, there must be little distance between them. So you can see these are 2 different units. So this is how we can calculate. So this one is right, but this one writing like this is not correct. So the answer for this one has to be D. So this is one way you can answer. Other way you can also use, that is, you can simply resolve these forces into components. Means we can resolve this force into 2 components. So we have vertical component here, we have horizontal component here. We can resolve this one into vertical component, and here it has horizontal component. And so in this case, due to horizontal component, there will be no rotation. So the rotation will be only due to vertical components. So this vertical component is 15 sine of 65 degrees, and this vertical component is also 15 sine of 65 degrees. And the distance between them, this distance, this is equal to the diameter. So we can draw this line here. So this is the perpendicular distance between these 2 component of forces, and this distance is 0.40. So in this case, our force, we have force time perpendicular distance. So the force is 15 sine of 65 degrees multiplied by perpendicular distance, that is 0.40. So if we solve this one, you will get 5.43 newtons meter. So the answer for this question is D. So you have 2 different approaches you can use. Maybe one of them sometimes will be easier to use and other one will be a bit tricky. So you can use any method, your result will be the same. Question 12 says a farmer is trying to lift the corner of a large water tank. She uses a metal rod as a lever. The vertical force from the farmer is constant and is always applied to the end of the rod. Which change must increase the upward force on the water tank? So for this purpose, simply we can assume first of all the force on the water tank is F1 and the force from the farmer, we can say this force is F2. So in this case, the product of f1 and d1 has to be equal to f2 d2. We are interested in f1, so we can make f the subject, so f1 has to be equal to f2 d2 divided by d1. For this question, it is given to us that f2 is constant because the force from the former is constant, so it means f2 is constant. Now if you look at given options, for option A it is given to us using a longer rod. Mean if we use a longer rod, we will increase d2 if we keep the pivot at this point. For the second part, it is given to us moving the pivot closer to the tank. Mean if we move this pivot closer to the tank, in this case we will decrease d1. So in this case we are certain, means we are 100% confident that f1 will increase. It doesn't matter how much we increase this one, it doesn't matter how much we decrease this one, f1 will increase. So answer for this question has to be A. Now if you look at part B, it is given to us using a longer rod. Yes, this one will increase f1. Moving pivot further away from the tank, this one will decrease f1, because in this case d1 will increase, so f1 will decrease because d1 will increase. So we don't know how much force will increase and how much it will decrease, so we don't know the exact numbers, so it means this is not possible. Using a shorter rod, this will decrease f1. Moving pivot closer to the tank, this will increase f1, but we don't know how much increase, how much decrease, so we are not certain, so this is not possible answer. Using a shorter rod, this will decrease f1. Moving pivot further away, this will also decrease f1, so this is also not possible answer. So the answer for this question is A. A nice question. Try to understand the logic. Question 13 says the diagram shows a ball of weight W hanging in equilibrium from a string. Equilibrium means that net force in any direction has to be equal to 0 and net moment about any point has to be equal to 0. So this is meaning of equilibrium. So this concept has to be clear to you. So these are two conditions for equilibrium. For this question, we need to find out which relationship between the magnitudes of T, P and W is correct. When we say F net is equal to 0, it simply means that forces, they should form a closed polygon, so forces should form closed polygon if net force is equal to 0. Closed polygon means that if there are 3 forces, they should form triangle, and if there are 4 forces, they should form rectangle, closed polygon. So triangle, it can be here, let's say, imagine this is one force, this is an other force, and the third force will be this way. So you see, in this case, net force is equal to 0. Now if you look at given forces, we have P and W. If this ball is in equilibrium, it means that the sum of these two forces, this one has to be equal to T. Magnitude has to be equal to T. So let's draw this one again. So the magnitude of these two forces, if we add these two forces together, has to be equal to T, equal in magnitude. So we can draw here. So this is our force W. So this one is W, and this is the sum of these two forces, mean the resultant of these two forces. So how we can find this resultant? Let's say this resultant is R. So R in this case has to be equal to P square plus W square and the root of this, because this is just a right angle triangle. And R in this case, we are talking about magnitude. So R you can replace with T, because the magnitude of R has to be equal to magnitude of T. So we have P square plus W square. We can also write down P and W in terms of T. So if you look at components of T, we have angle theta here. So this component will be T cosine of theta, and this component will be T sine of theta. So in this case, P has to be equal to T sine of theta in magnitude, but in opposite direction. So we have to take the square of this. and W has to be equal to T cosine of theta in magnitude but opposite in direction. So we can take the square of this one as well, because we are talking about magnitudes here. And question is also asking you to find relationship between magnitudes of T, P and W. So the answer for this question has to be C. Question 14 says, which expression for pressure is correct? Pressure simply is equal to force over area normal to the force. So we can say normal to the force. So area normal to the force. So very important one. If you have question like this, let's say the force is at an angle, so you need to find out pressure due to this force. So you have to take the vertical component of the force that is perpendicular to the area. Means in this case, if this is force F, you will be taking F sine of theta. So the P in this case will be equal to F sine of theta divided by a contact area. So very important one. So the answer for this question has to be A. Question 15 says a ball has a mass of 0.50 kgs and a volume of 1.3 times 10 to minus 3 cubic meters. The ball is floating in equilibrium on still water. The two forces that act on the ball are its weight and upthrust due to the water. The density of water is 1.0 times 10 to 3 kgs per cubic meter. What is the percentage of the volume of the ball above the surface of the water? So in this case, first of all, we can imagine this one is the water. So here we have water and the ball is placed inside this water. So we can draw the ball here, and this ball is floating inside this water, and this part of the ball, this is inside water, so this is inside and this one is outside, and this is what we need to find out. We need to find out the percentage of the volume of the ball above the surface of water. So we have to find out this one. So in this case, there are two forces acting on the ball. One is the weight that is acting downwards, and the other is the upthrust, and these two forces are equal in magnitude. So we can say here we have upthrust. So these two forces are equal in magnitude. So it simply means that in this case, mg means the weight of the ball. This is equal to upthrust, and upthrust is equal to weight of fluid displaced. Weight of fluid displaced. So we can say this is mass of fluid displaced times g, and mass of fluid displaced, we can say this is equal to density of the fluid times volume of fluid displaced times g. And from here we can simply cancel this g with this g, and we can write here the mass of the ball. This has to be equal to density of the fluid times volume of the fluid displaced, and mass of the ball we can write down, this is density of the ball times volume of the ball. But in this case, we no need to write down in terms of density and volume, because directly the mass of the ball is given to us. So we can simply write down mass of the ball, that is 0.50, and density of the fluid we have, that is 1.0 times 10 to 3 kgs per cubic meter, and here we have this is volume of fluid. So we can find out from here volume of fluid displaced. Volume of fluid displaced, from here we can find out volume of fluid displaced in this case will be equal to 0.0005 meters cube. So this is the volume of fluid displaced, and we need to find out volume above the surface of water. We need to calculate percentage of the volume of the ball above the surface of the water. Percentage, so we can say percentage of volume above. So we can say volume above. So this one has to be equal to volume above divided by the total volume of the ball. So this one has to be the total volume of the ball. So volume above, simply we can find out volume of the ball. We can write down volume of the ball minus volume of the fluid displaced. So we have volume of the ball, that is 1.3 times 10 to minus 3 minus we have 0.005 divided by volume of the ball, and we have to multiply by 100. So volume of the ball is 1.3 times 10 to minus 3, and if we multiply this one with 100, we can find out volume of ball above the surface. So in this case, if we solve this one, we will get this is 62%. So this is the answer. A nice question on upthrust. For question number 16, we need to find out what is the work done by the tension force on the man and the buggy. And for this question, it is given to us the man and the buggy, they travel a distance of 20 meters. So we need to find out the work done by the tension force on the man and the buggy. So simply, this is very straightforward question. So the work done in this case will be equal to the component of tension. So tension has two components in this case. So one component is vertical, so we can draw this is vertical component. Another component of tension is horizontal component, so this is horizontal. So in this case, we have to take component of tension in direction of displacement. So that component is this one. So this is T cosine of 40 degrees. So we can write on here, we have to take component of tension in direction of displacement times displacement, and displacement in this case is 20. So T in this case is 200. So we have 200 cosine of 40 degrees multiplied by 20, and if we solve this one, we will get 3.1 times 10 to 3 joules. So the answer for this question is B. Pretty straightforward question. Simply you need to understand work is equal to force times displacement in direction of force. So that's the key concept. Question 17 says a ball is thrown vertically upwards from the surface of the earth. Which statement describes the energy of the ball as it rises through the air? So in this case, simply we have a ball. So you can imagine we have a ball here. We can also imagine it is placed on the ground. So here we can take H is equal to 0. So this is our reference level. So GPE here will be equal to 0. Then kinetic energy of the ball at this point will be maximum. As this ball will rise, it will rise. So the change in GPE in this case will be positive, mean this will increase, or we can say change will be positive, or simply GPE will increase in this case. And change in kinetic energy will be negative, means kinetic energy will decrease. And when the ball will reach the maximum height, kinetic energy of the ball will be equal to 0, and GPE of the ball will be maximum. So these are the points we need to understand. Now if you look at given options, it is given to us the kinetic energy of the ball decreases. This is true. Potential energy of the ball decreases. No. Potential energy increases. So this is incorrect. Kinetic energy of the ball decreases. This is true, because the change in kinetic energy will be negative. Potential energy increases. Yes, this is also true. So the answer for this question is B. If you look at option C, kinetic energy of the ball increase. This is incorrect. Potential energy decrease, incorrect. Total energy of the ball increases. No, total energy remains constant. So the answer for this question is B. Question 18 says a lamp is suspended in equilibrium from a fixed port by 3 identical wires. The weight of the lamp causes each wire to have an extension of 0.40 centimeters. The height h of the lamp above the floor is measured. The middle wire suddenly breaks and the lamp falls a small distance as the extension of remaining 2 wires increase. The wires obey Hooke's law. When the lamp is in equilibrium, the height h of the lamp above the floor is measured again. What is the difference between the two values of h? So first of all, we can imagine in this case the weight of the lamp is W. Let's say this is W. So the tension in each wire will be equal to W by 3. Now we need to understand Young's modulus. Young's modulus is equal to FL over A times delta L. From here we can write down delta L will be equal to FL divided by A times Y. But for this question, it is given to us these wires are identical, so L is the same, A is the same, Y is also the same. So from here we can write down delta L is proportional to F. So these two quantities are proportional, or we can say in this case delta L over F, this is equal to constant. So simply we can say this is equal to constant. So in this case, first of all, F is equal to W by 3. So we need to find out new value of F. So we can write down here in a beautiful way. We can say this is delta L1, and here we have this is F1, and here we will have delta L2. This will be divided by F2. And for this question, we need to find out the difference, delta H, and delta H will be equal to delta L2 minus delta L1, means the difference between these two. Now we need to find out value of F2. In order to find value of F2, we can redraw this. We can redraw here so you can compare. Now we have two wires, they are extended more, so we can draw this one bit longer. So here we have the same weight hanging here, so this is W. Now we have only two wires, so the tension in each wire will be equal to W by 2. So in this case we can write down delta L2, this one has to be equal to delta L1 times F2 divided by F1. So we have value of delta L1, that is 0.40 centimeters. So this is in centimeters, and we have F2, that is equal to W by 2. So this is W by 2, and we have F1, that is W by 3. Now we just need to simplify. So we are already done with this question. So you see W we can cancel with W, so we left with 3 divided by 2 times we have 0.40. So if we simplify this, we will get 0.60 centimeters, because we are using centimeter here. So this is value of delta L2. Now we can plug in here, so we have 0.60 minus we have 0.40. So the final answer we will get, that is 0.20 centimeters. So the answer for this question is A. So this is how you need to answer. Simply you need to understand what is new value of tension in the wire, and if you have new value of tension in the wire, you can find out new value of extension, then simply subtract. So the answer for this question is A. A beautiful question, and this technique is very useful. Tricky questions are based on this technique. Question 19 says the force extension graph for a spring is shown in the figure. What represents the work done to extend the spring? Work done, simply understand, work done is equal to force time displacement in direction of force. In this case, force is not constant. Force is changing with extension, so we have to consider average force times d. Average force, we have F is equal to 0, we have F is equal to maximum value, so we can say maximum value plus 0 divided by 2. So the average force by extension, we can say delta x. So we will get here 1 by 2 F times delta x. So it simply means that this area is representing work done. So this is simply equal to area under graph. So we can say area under the graph. So area under the graph is representing the work done under the graph. So the answer for this question has to be A. Question 20 says, in an experiment, a student uses a microphone and CRO to analyze a sound wave. The diagram shows the trace on the screen of the CRO. The student is expecting a sinusoidal waveform to be shown on the screen. Which changes should the student make to the time base and the Y gain of the CRO so that the screen shows a continuous trace for one complete cycle of the waveform. So in this case, student is expecting to see this on the screen, but student cannot see this on the screen. Means student cannot see one complete cycle of the wave. So it simply means that wave is very big. So how we can make this wave to be seen on the screen? One, we can make the screen of the CRO very big so we can see the wave. So let me write down here changes. So what changes we can make? So we can make screen very big, means we can have CRO with very big screen. So we can say make screen big. So this is one thing we can do, but this is practically not possible. The second thing we can do is we can compress the wave. We can compress the wave. We can compress the wave. So if we compress, we have to increase time base. So we have to increase time base, and we also have to increase Y gain. So we have to increase this one, we have to increase this one. So in this way we can compress the wave. So for this question, simply answer has to be D. So we have to increase. So when we increase time base, it simply means that, first of all, let's say we have 2 millisecond per division, or it can be per centimeter. So let's say is mostly it is given in centimeter per centimeter. Now if we increase this one to 10 millisecond per centimeter, it simply means that we have compressed the wave so we can see the full wave. And same is true for the Y gain, means the voltage on Y axis. So this is the voltage. So if Y gain, for example, is, let's say this is 4 volts per centimeters, we can increase this one, let's say, to 12 volts per centimeter. So in this case we will compress wave along vertical, along Y axis. And if we increase the time gain, means the time base, so we will compress along X axis. So in this case we can see the wave. A beautiful question, simply testing your real understanding of CRO. Is also testing, have you ever used CRO or you have not used CRO in your practicals? If you have used CRO in your practical in physics lab, so this question is very basic one. Most of the time when we have to do any experiment about CRO, we want to see the sound wave, we adjust the time base and we adjust the Y gain. So this question is about practical, means about lab. Have you ever used CRO or have you ever not used CRO? So this is just testing your practical skills. So if we cannot see the wave on the CRO, what we used to do, we simply increase the time base and also we increase Y gain. So then we can see the wave. Beautiful question, just testing your practical skills. I hope this video was helpful. We have discussed 10 very nice questions from this paper. I hope this video was helpful, and if this video was helpful, please like and subscribe because your encouragement is very important. And rest of the questions I'll be uploading by tomorrow. And also if you have any questions, please leave your questions in comments. And if video was helpful, like and subscribe. If you need more help, also join Patreon. And the link for Patreon is in description of this video.